Hello and welcome to the VISTAS tutorial series. In this first of 3 tutorials, I will go over basic use of the program, including how to create your first visualization and how to add additional visualizations to your scene. The main application window has 3 main components. On the left-hand side, we have the project tree, which will contain our imported data and the visualizations that will utilize that data. On the right, we have the main viewer panel. Here is where we will visualize our datasets into 3D. On the top of the viewer panel, we have our scene selection and buttons for opening legends. Additional viewer panels can be added under the View tab in the main toolbar above. Along the bottom, we have the global timeline. Datasets with time series will be viewable utilizing the playback commands. Let's create our first 3D visualization in VISTAS. First, we need a dataset with elevation data. Under File, click Add Data. ArcASCII is one of the many file formats that VISTAS supports. The other way to add data is by clicking the Add Data to Project button on the main command bar. Now we are going to add in our time-serialized ArcASCII dataset. Now that our data has been loaded, we can create our first visualization. Visualizations in VISTAS are contained in scenes. To add a visualization, click on the Visualizations tab, right-click on a scene, and then click Add New Visualization. This will open a window where we can select what type of visualization we want to create. These visualizations are provided by visualization plugins written by other scientists or developers to incorporate their datasets into VISTAS. For the purposes of this tutorial, we will select 3D terrain and color. In this window, we have 4 tabs: Data, Info, Options, and a 4th window for visualizations that support filtering. Under the Data tab, we tell the visualization which datasets to use. For this visualization, we need to choose 2 grid formats. Here, I'm going to choose the 2 datasets we loaded earlier, but other visualizations can accept data in an array format. Under the Info tab, we have basic information about the visualization being used. These are specified by the plugin developer, allowing the developer to identify what formats can be visualized by the plugin. Under the Options tab, we can specify which attributes of the dataset to view and other options specific to the dataset. This 4th tab is an optional tab available to plugins which support filtering. The filter can allow the user to narrow or widen the range of values to visualize from the given dataset. Now that we have specified the data for this visualization, we can close the visualization window. And now we have our first 3D visualization in VISTAS. The scene inside the viewer panel can be manipulated by holding down the left mouse button. You can zoom in and out using the mouse wheel, and you can move the visualization by holding down the Control key and holding the left mouse button. Now that we have a visualization rendered, we can use the plugin options available to us. These are the same options that were available in the Options tab on the visualization window. In the Terrain and Color visualization, we have the ability to change the colors associated with the minimum and maximum values of the dataset. We can also change how the visualization renders the data on the terrain by discarding points with no data, or whether to use per vertex coloring and lighting. Other visualization plugins will have other options associated with them, as will be shown in another tutorial. The last thing I will cover today is the VISTAS timeline. Since we have a time-serialized dataset, we can step through each timestamp and visualize the changes in the terrain over time. The gearbox to the right of the timeline will open a small window containing additional playback options. The Live Update button enables the user to click and drag the playhead to any point in the time series while also updating the rendered scene. When Live Update is not checked, the scene will only update if play has been pressed or if the playhead is dropped to a different point on the timeline. Changing the animation speed will increase how quickly the time series is played through. The animation speed can also have its value changed manually by entering an exact value. Showing every frame will force low-end machines to render each timestamp of the dataset. When you have finished creating your visualization, you can save the project by clicking File, Save Project, and specifying a name for your project. Thank you for watching this tutorial on VISTAS.